And second part of video homework, let's talk about problem 3. So in problem 3, we know that xt is the Poisson process. So we have p xt equals k equals e to the minus lambda t, and the k lambda t to the k. And we need to prove if the limit when t is equal to infinity, xt over t equals lambda. So here is the proof. We need to use the Chebyshev inequality here. So first, with some property of Poisson process, we know that the expectation of xt is lambda t, and the correlation of xt, which is e expectation of xt minus expectation of xt, to 2 is lambda t. Okay, so right now we can change the goal of our proof, which is this one, right? This is the goal of our proof. So it can be written in another way, like this. The probability of is 1, right? And epsilon should be close to 0, right? So we have that if the probability of this part, oh shit, if the probability, sorry for that. Okay, there you go. So the probability of this part is 1, then we know that the probability of this one larger than epsilon, which is probability of this one larger than epsilon, should be 0, right? Then we can use the Chebyshev inequality here. So the probability smaller than expectation of right, this is the Chebyshev inequality. So, and we know that the expectation of xt minus lambda t to 2 is lambda t, right? So this part and this part is strongly related, so we can use the equation above to get the result of the of this part right? We can use this to get this. How do we do that? Yeah, that's a very easy math. So we know that if we take t out of this expectation, let's write this over. If we take t out of it, it should be t to 2 and xt minus lambda t. Right, and this is the same to the equation above, so it should be right. Okay, this is the result of the expectation of xt over t minus lambda to 2. So this part, so the limit probability of t xt minus lambda larger than epsilon smaller than t to 2, epsilon to 2, and lambda t. Also, there is a condition here, t is close to infinity. Right. So when t is close to infinity, and the limit of this part should be 0. So we have proved that the probability of xt over t minus lambda and larger than epsilon is 0. So the probability of xt over t minus lambda smaller than epsilon is 1. So we have proved what we need to prove, right? So we can get limit t is close to infinity, xt over t is lambda. So that's all about problem 3. Thanks for watching.